So first up today we have Mark Duck. Mark is the PTE ICS Security. It does PTE ICS Security with Shell Global Solutions. He has over 30 years of experience working on automation, IT, and security projects in multiple industries in North America, South America, Asia, and Europe. For the last 11 years, has 11 years of experience with Shell Oil Company and Shell Global Solutions, which is a process technology and operation consulting organization working on capital projects responsible for the implementation and assurance of industrial cybersecurity controls for automation systems. He's a certified CISSP and GICSP. He's a key contributor to the development of Shell's global industrial cybersecurity standards. So join me in welcoming Mark.
Well, good afternoon, and I want to thank PAS for giving me this opportunity to speak today. So I'm going to talk about Shell's ICS security strategy, or basically our ICS cybersecurity management system that we use in the OT environment. So what do we do at Shell? We have four main lines of business: upstream, downstream, integrated gas and new energies, and our projects and technology group. So in upstream, we explore and produce oil and gas reserves. In downstream, we convert oil into a range of refined products and sell them. And then in integrated gas, manufacture liquid natural gas and a range of gas to liquid products. And we also have a new energies group, which is looking into new low carbon footprint type opportunities for the future. And then in our projects and technology group, which is where I work, we're responsible primarily for delivering the capital projects into Shell's lines of business. And it also houses the R&D function. And many of the technical experts we have across Shell, across the various disciplines, like electrical, mechanical, civil, and in this space as well, are in P&T. So today I'm going to talk about how do we manage the ICS security risk within Shell. So there's a term that I'm going to throw out, process control domain, that we use it so often that I'll be using that in the presentation, but the process control domain houses our automation systems or our industrial control systems. So this is the intent of this slide is to point out that this is not just about technology. It's about a spectrum of things that we pull together as part of our management system. It's anchored by a process that we call managed PCD integrity. It's called PCD integrity. In the past, it's been called PCD IT security, but recently we've renamed it to integrity to link it to our HSSE type processes within the sites. So we're linking that safety and security together that way. So again, it's a process. We call it managed PCD integrity, and it's supported by various things. We have leadership teams in place that are responsible for the process. We do have technology that is supported. We'll talk about our secure plant technology, and again, that's a managed service from IT. We use reference architectures to standardize things. We do have collaboration between our IT folks. We call them IRM, Information Risk Management, and even other parts of IT, as well as working alongside our engineering folks. Standards and recommended practices. We have an assurance model. We work with our suppliers to educate them. We have workforce development process, and a community of practice to kind of tie all our folks together so they can talk and share. So within Shell, in the past, these lines of business have had independent business management systems. And I guess about a couple of years ago, Shell started a project to identify common processes across these lines of business. And one of those processes that was selected was this managed PCD integrity. So the idea is to standardize these processes and have one business management system for those processes across Shell to improve efficiencies. So we've been working on that a lot last year, and it's resulted in a model and and kind of a revamp of our internal standards and how we approach things to manage the process. So it's anchored by at each site, and we have a lot of sites across the globe, but at each site essentially has a site focal point that is responsible for the day-to-day implementation of our controls that are part of the standard, as well as sustaining those controls over time. And then we have a site process owner that is accountable for the process at the site, and again supports the site focal point and is part of a business leadership team. And then we have a cross-business leadership team that is responsible globally for this process across Shell. And they have regular meetings to talk about the health of the process, and it's a continuous process to move things along in terms of improvements. So this is the basic hierarchy. There's other things involved, but this is a basic hierarchy of how it works. And it's supported by, again, standard requirements and an assurance model, which I'll talk about. So under this, within this this business management system that we have, there's some standard documents that we have, and one of them is a standard. And the standard is those mandatory requirements that we have to implement in a given process, in this case, PTE integrity. We also have a document of recommended practices. This is a little bit of a shift within Shell. In the past, we've sort of had one standard that represents our minimum requirement. And now we have a standard that's possibly even less than that, but the sites are expected, the realization is that the sites have different risk profiles at the end of the day. And so the sites are required to implement the minimum, or these standard requirements, and then do some form of risk assessment to determine what, if any, of the recommended practices they should be deploying. So it's a risk-based approach and lets the sites implement the right level of security. In our documents themselves, we're starting to organize them according to the NIST categories to sort of tie that to NIST. And when we're coming up with these controls, we're reviewing not only the NIST standard, but the IEC 62443 and even others. And again, to come up with these controls, we're working with both IT folks and engineering folks together on these initiatives. So some additional roles that are used to support the process. We talked about the site focal point. And so we also have a role called technical authority. Technical authorities are folks that have been formally assessed for their knowledge in this space. And their role within the lines of business is maybe to support the site focal points in terms of management of change, making sure that we're following and interpreting our requirements correctly, and when we implement new controls or we change things. They also have a role within projects. So we do a lot of projects, and we roll those into the lines of business, and those projects need to have these controls built in when we hand them over to the business so they can operate this process. And so the TAs are involved in assuring, projects tend to be document-centric, and so they're assuring these documents and assuring that the service providers are delivering the controls that we expect. Subject matter experts, we try to identify, again, the same hierarchy is used across all the disciplines within Shell, not just PTE integrity. But the subject matter experts, we try to identify a few of those across Shell per discipline, and they will help with maybe some more technical things, interpretations of where there may be some gray area in our requirements, and get involved in some technical situations. Principal technical expert, there's at least one of these per each discipline within P&T, and amongst other responsibilities, they support the TA and the SME community, making sure that we have a good, healthy community and enough folks to do the work that needs to be done in that discipline. And again, these roles can be found not only in engineering, but also in the IT space. The assurance model. So we have a three-tier assurance model. We call it lines of defense. And the first level in this assurance model are activities and tasks that happen pretty much on a day-to-day basis at the sites. And so as part of standardizing all these processes, there's a process they use called a health check. And there's a template with questions, and that's done on some frequency by the sites to do sort of a self-assessment. Then there's things like GO-SEES, maybe an internal audit, just site folks involved in that. And, and then with LOD2, which is done periodically at some frequency, our IRM folks get involved and help us perform this external review of the site. And it involves site resources as part of the assessment, but we're bringing in folks from IRM and maybe some TAs to assist and do a periodic assessment of the controls at the site. And it's also using, I'll talk about Secure Plant, but it's using some tooling that generates reports out of our Secure Plant technology, which gives inventory information, how we're doing on patching, are our antivirus signature files updated, and so forth. And so that's used as part of the assessment. And then level 3 is our traditional Shell internal audit organization. Really nothing changing there recently, and it's pretty much a totally independent audit. Outside folks come in and audit the site. So this slide, I'm going to talk about the technology. Secure Plant, we call it Secure Plant. It's been it's a managed service, but it's also a partnership with Cisco and Yokogawa. And it's essentially our DMZ between our process control domains and our office domain, and of course any other domain beyond that. And the objective is to automate as many of these cybersecurity controls as we can. So the first one is asset inventory. So when and we've also been, over the last 3 years we've been rolling this out. I would say we're about somewhere between 80 and 90% of all the sites have this technology now across Shell. And so as it's rolled out, the asset inventory, the process is that each system is explicitly enrolled into this system. And so Windows machines, network equipment, and so forth gets enrolled. And so we have that asset inventory. And then the system can report on software that's installed in the Windows boxes, the versions, and same thing with the network gear, like the iOS versions and so forth. And so there's been challenges around that. Not everything is necessarily in the network, so there is some manual input into that as well. Access control, it has a robust remote access portal where we require two-factor authentication. So an example would be somebody maybe sitting in the office domain, or even potentially a service provider, third party, needs access to some equipment in our process control domain. They would access this portal for remote access. They would have a token, and they would use that to then log into the portal. And from there, based on their rights, they would use typically RDP, for example, to then access a machine in the process control domain. Operating system security patches. We do have some partnerships with some of our major suppliers, and they'll feed, there is a connection with Secure Plant or an integration with Secure Plant, and they provide qualified patches into the system, and then those are distributed down to the sites. They're not automatically installed. The site focal points are still responsible for installing those patches, which often require reboots, for example. Antivirus, again, the point there is that we want to automate the deployment of these signature files, which come much faster even than the patching. And that's more automated. Those do get pretty much installed automatically. There's not a manual installation of that. Event log management. We haven't had a robust event log management in the past, but we have a project underway now to integrate our event log management into our office domain cyber defense team. So in the office domain, they have more advanced tooling that they've been using over the years. I would say we're behind on the OT space relative to our IT or business space. But we have a cyber defense team, and they have tooling that ingests log files, and it's based on Splunk, and they can crank through that data and pick out maybe interesting events that need to be investigated or followed up on. So we're in the process of integrating our process control domain logs into that system as well. And I think one last thing on this slide, PCD hosting. We have another technology. It's another IT managed service. In the past, like you typically at level 3 in the Purdue model, we have, the businesses over the years have deployed applications at that level, maybe above the control systems, but not in the office domain. And they're responsible for the hardware, the operating system, and the application. And so the idea with the PCD hosting service is to let, to have a managed service to manage the hardware and the operating system, and then the business would just have to manage the application. Reference architectures. The objective here is to try to standardize. You know, we have a lot of sites across Shell. We try to keep the suppliers that we work with to a minimum, and within that set of suppliers, we try to standardize the way we deploy their kit. And so on this slide, I'll talk about major suppliers and minor suppliers. For example, on a project, we would have a major supplier providing the bulk of the automation system, and with our major suppliers, we maintain toolkits. We work with them, and we standardize many of the ways we deploy their kit. And for example, function blocks. We try to standardize the way we deploy and maybe configure function blocks. But another thing that we do is in terms of zones and conduits, from a network architecture point of view, we try to standardize that. So we put together some network architecture drawings, and we get into agreement with the supplier on that. That goes in the toolkit so that when projects come along, they have a good starting point. You know, they don't have to start from scratch. And in most projects, there's always a set of these third-party suppliers to bring in packages. We call them third-party packages. And we want to standardize the way those packages are deployed as well and how they interface into the DCS. And so we'll work with those suppliers, again, to create a reference architecture so that we're trying to do that the same way across Shell. So, the idea here is to try to standardize and do things the same way. So workforce and knowledge. So again, this is common across the different disciplines within Shell, but within each workforce or discipline, we have workforce development materials and a process in place to progress employees over time with their knowledge and skills. And that involves, job competency profiles, recommended training, self-assessments, and maybe in cases like TAs, more formal assessments of their knowledge. And so the idea would be, in this space that we work in, we call it, PTE integrity. It's really a hybrid skill set required, right? You need IT skills, and you need, engineering skills, and so how do you get that skill set? It's tough, but a roadmap might be, a person would work on a project and work with the automation team to deploy a system, and they would gain knowledge around industrial networking and architecture, operating environments and hazards, process safety management, et cetera. And then maybe in another project or another operational role, maybe work for IT for a while, and maybe pick up things around business risk management, cyber incident response, IT audit and compliance, those sort of skills. And so over the course of a career, you kind of build this hybrid skill set. And then kind of rounding out things, knowledge of IT architecture, networking and communications, data management, all these are skills that we need to be successful in this space, essentially. Community of practice. So we have a lot of folks involved in this space within Shell. We have the site focal points, TAs, SMEs, et cetera. And we use consultants that are not in those roles I just mentioned. So there's a lot of a need to communicate across all these folks. So we have these communication channels. For example, a global network. We have bi-monthly meetings with the site focal points and TAs to get together and talk about the interesting topics that they've agreed that we need further exploration of. And so that happens. And there's usually like 2 of those to accommodate the different time zones across Shell. Technical authority meetings where we bring the TAs together to talk about assurance-related topics. We also have forums. We have a couple of forum mechanisms within Shell that we can share on a more ad hoc basis. Knowledge repository. We have these things called SPOAs or single points of access for knowledge for a discipline. And so we're setting that up now under this new business management system. And so the idea is to have a common repository. It's a challenge, and I'll get into that in a little bit too, but managing knowledge across such a space is difficult, but we want to be able to keep lessons learned, document templates, solutions to technical problems. We want to keep that. We'd like to keep that centrally located and easy to access. Projects tend to be document-centric, so we want to have good starting points or good templates for projects to start with for those deliverables. And ideally, bring folks together face-to-face occasionally in regional and local meetings. So PCD integrity in projects. So I mentioned projects and technology. We're delivering projects into the lines of business all the time, and we have this funnel of projects that are coming in. So the objective is that when a project is handed over to a site, that we can turn the crank on this managed PCD integrity process without having to go remediate and add controls to the systems that possibly weren't done correctly during the project. So it's a challenge within projects to make sure that our suppliers, that we get the requirements to them, that we expect them to implement, and that we assure that to make sure that it's done right before we do hand over to the business. We have a we have a project management framework we use within Shell for major capital projects. We have certain controls and assurance models in place. Again, I mentioned the technical authorities that support that, specifically for each discipline, including this one that we're talking about. Again, I mentioned the toolkits to give the project a starting point without having to start from scratch. And one of the keys in the past, one of the keys to success has been having what we call a PCD integrity project focal point. And the way we've executed projects in the past is that we may have a contracting model such that Shell's directly talking to the MAC or our main automation supplier and the EPC, as well as our different third-party suppliers. So all this stuff is networked. Virtualization is coming into the picture, and so this focal point becomes sort of the glue that manages all these interfaces and making sure that that all this stuff works together, integration is done right, and the cybersecurity controls are implemented properly. And in the ideal case, that resource would begin the project during the feed phase and would stay on the project all the way through build, commissioning, startup, and handover. So one of the things we're doing now, Shell's been on this journey with respect to PCD integrity for, 15 years or so at this point. I've been involved about 10 or 11 years myself, and we've had standards all along the way. We've been developing internal standards around this space for a long time, and we've been talking about recently, we really need to get away from Shell standard, Shell clauses about our requirements and start using an external standard. So we're in the process of updating that now, and this is a project standard. So let me clarify on the what we call operate phase, when the lines of business are operating this PCD integrity process. We have this business management system and that standard and that recommended practice I mentioned earlier, which involves a risk assessment to select those recommended practices. Well, this is primarily a project standard, and it's a little bit different. And so what the objective here is that for this next rev of our standard, we're going to go sort of referencing 62443 in a substantial way, and specifically two of the parts. Part 3-3 is system security requirements and security levels. And so the idea would be that we would specify a minimum set of system capabilities in the standard. And that would be things like the system shall have the ability to authenticate a user. And then the next part, 2-4, is security program requirements for service providers. So those are service provider capabilities. A service provider may be an EPC. And so we'll specify a minimum set of service provider requirements. And then there's probably going to be some Shell-specific things in there. We probably won't get rid of all of them. And then we would expect the service provider to do a risk assessment. And there's some standard risk assessments out there, including one of these parts is a risk assessment procedure, and there's others, ICS-specific risk assessment procedures that can be used. And that risk assessment would figure out, or the output of that would be what additional controls we need over and above those minimums for the project to be what we call ALARP in terms of risk reduction. And ALARP, as low as reasonably practical, that's a term within Shell, it may be an industry term as well. And so the idea there is that the output of the risk assessment plus those minimum standards would be the project cybersecurity requirement specification, and it would go off and execute that. And then this risk assessment would include, as the system under consideration, the safety instrumented system as well. I don't know if I'm seeing the signs. How much time? 4 minutes. Okay, yeah, I missed the signs. So anyway, let me move forward. Challenges and lessons learned. I'll just leave this up here and stop now, and you can kind of read through those. And then I think we wanted a little bit of time for questions. I have some. Okay. Yes.
questions for Mark? Thank you, Chad.
All right, and thank you, Mark. So when you get to the point where you're assigning a focal on a project to follow the project through the rest of the process, are you choosing an SME that has knowledge in that space, or are you just handing it off to like a project manager that knows how to run a project?
It's typically not an SME, but it is either a shell staff or even a contractor oftentimes that has the skill set. Like we look for the certifications like GICSP or CISSP and so forth. And again, that's one of the challenges. Finding those people are hard, and so we develop these relationships with these folks and try to get them up, through a few projects and kind of keep those folks close. But those are the type of folks that would execute that role. Yeah. It's supported by the TA community.
Alan Clark, American Star Linux. How long does it typically take for you to execute a project, I guess, with the cybersecurity?
It could literally be years. Like these are major capital projects, like a chemical plant or an offshore facility, a host offshore in the Gulf of Mexico, for example. So that is a multi-year engagement typically.
Any more questions? More.
How are you going in remediating the existing facilities and bringing them up to standards? How does that fit in with the model?
Yeah, that's a good question, and that's why we want to try to get this right up front in projects. But when we started this, I would say, years ago, we did have to go remediate a bunch of sites, and so we would spend up projects and budget money and go tackle remediating these projects or these sites, not projects. And so at the end of the day, that requires budget and time. And so you have to convince leadership to provide that budget and time. And so that is a challenge. But yeah, the business has to own that risk, and so they have to allocate the funds to remediate the sites that need to be remediated.
Okay, one more and then we'll have to cut it off. Thanks.
Sorry. So have y'all also implemented anything to help track maturity over time so that you can see the big picture of progress of where you were at some baseline versus current progress?
I think the short answer to that is no, but we do have, again, some tooling that IRM has put together for us, and it shows kind of technically where we're at. But I would say as a cybersecurity management system, I would say no. We're probably not measuring that, and that's probably an opportunity for us.